which is great tee up. But I wanted to sort of just take it nice and slow and show you very concretely, kind of physically, what does this actually mean? What does it feel like? Not all of us are so deep in the space, and so maybe build some intuitions. I have a few slides. This comes from a recent short lightning talk. I'll go over it, but I really want to switch over into demos and sort of show you what this actually will look like in practice. And if you have questions, you can ask them live, because that's what we're here for, and that's why we have a small group. All right, so at the end of the day, the project is called Soft Navigations because that's the end goal that we wanted for Core Web Vitals. We want to fold in the ability to measure these ephemeral, loosey-goosey soft navigations, which has been hard to define. It's taken a while. But practically what we've delivered at the end of the day is we've realized there's two new capabilities the performance timeline needs on the web platform. And I want to focus on the one I'm excited about, which is interaction contentful paint. So we really haven't talked about the low-level details of what even is this performance timeline, the JavaScript interface for recording and reporting a web page lifecycle. So unless you work on the performance timeline, you can't raise your hand. Who here knows what I'm talking about when I say those words? Okay. No, don't raise your hand. Of the people who are here for the meetup today, who knows exactly what I mean when I say using the performance timeline of the web platform? That's amazing. Okay, this talk is for you. Either you're very shy or you work on it and you don't know if you're allowed to raise your hand. So in case you haven't, because I didn't see any hands, it's a JavaScript API for recording what's happening on the page from a performance perspective. And then you could use this to report, or the API reports to you, the JavaScript developer, and then you could report it to your own servers and aggregate it. It's useful for pinpointing bottlenecks, for measuring user experience, and eventually, hopefully, driving optimizations. All right, so here's a screenshot. I'm going to switch to a demo to show you this, but I think it's nicer to focus on a thing. This is kind of an experimental feature in Chromium. You got to enable it with a flag, and if you do, it tells you when the browser thinks that things load. Okay, if you've ever used the API that Annie was talking about, largest contentful paint, it's trying to let you understand when did the primary content of the page appear. Did it take a second, which is kind of satisfying, or did it take 10 seconds, which is like enough to get bored and bounce? And so this feature in Chromium will draw a nice green box to say, this bit of text appeared in this moment, in this frame. This is the first time the user saw this text. Same with images, same with everything that's on the page. So you looking at this screenshot see a bunch of green boxes around content that you can see anyway. The green boxes aren't helping you visually right now, okay? I'm just trying to help describe what the browser sees under the hood by drawing a picture around it. Because you, the developer, aren't getting a movie screen rendering of everything the user's doing on your website for every user that's out there on the web, okay? You, the deployer of a web page, you at best get to consume performance entries like this. This is the performance timeline, okay? When your site runs on some user's device, you're allowed to ask, every time there's a new largest contentful paint, let me know. You're getting insights about the performance of your own page in the wild, all right? And you only get a little bit of metadata. You get sort of the time that the LCP element happened, what it was that rendered, which image, which text block, how big was it, and kind of very interesting details, but you only get a little bit of data. And commonly, developers will upload this to a database, aggregate thousands of runs over time, and you get this nice little trend line. You know, things are improving. Oh no, things got a lot worse. Call everyone into the office, okay? Does that help illuminate? I think we have a bunch of experts only, and I'm going to stop. Okay. But not everything we do on the web is a navigation, okay? And he teed this up fantastically. So sometimes we just get no insights at all. So the reason there's no green boxes here is because this is an example of me clicking a link that soft navigates, okay? That means that the site chose not to go back to server, not to start with a blank white page, not to render everything from scratch. It chose to dynamically update itself. And so when you do that, this is what you get from the performance timeline for all of history until recently. And so this is what you upload to the cloud. This is what you put in your database, and this is what you record over time, unless you use a fancy product, okay? No callouts. So that's what we're fixing, okay? I teed it up nice and slow. I'm pretty sure you could have predicted my next slide. The yellow squares or rectangles is a different type of performance entry. Now we are actually observing interactions and dynamic updates. It feels exactly familiar, like the green one. Okay, green, yellow, who cares? Under the hood, completely different. Okay, way harder, trust me. Okay. And so you get a different value on the performance timeline. You get not a largest contentful paint, which is specific to navigations and loading. You get a thing called interaction contentful paint, which I promised you I was excited about. It's a little bit different, but it's more similar than it is different. So it should feel very familiar. You still get an element. What was it that painted? You still get a timestamp. You get a bunch of interesting details. So this is the current shape of the API as it exists. And I'll show you a live demo in a moment. And now you can upload it. You can add it to the database. This is one half of two-part API. The other part is the actual self-navigation thing. So this is you interacted, the page updated, here's how long it took. The other part is you interacted, the URL changed, that's like, now we're upgrading you to a navigation. Okay, so you use, one gives you performance data, the other gives you, did it actually navigate? All right, under the hood, it starts with a user interacting with the page. Now we have a metric. We have a metric called interaction to next pane. Not only does Chromium have this metric, Mozilla Firefox also has this metric. It was part of a great intro project. So this is a wonderful result. Now that moment that you see here, when the developer's waiting to get a signal that the user interacted with the page, it's the most important part of responsiveness, okay? You have to nail this. If your page is slow loading or like very janky or whatever, and the user is confused, why isn't it working? Nothing's happening. It's very frustrating. And that is what interaction to next paint covers. It literally says, I don't care what's in the paint. I don't know if that was a useful result or whatever, but you need to be able to handle the event and paint something reasonably quickly. And there's a metric for that. But we knew even when we launched this is necessary to be fast, but it's not really sufficient to like solve all of web's problems. Okay. If I hit buy this piece of clothing online, it's nice that the button kind of is clicky, but I really want it to get added to my cart. Like I really want the net effects of that interaction to actually happen. So we wrap the code that runs, we observe it with a context. Internally in Chromium, we call it an interaction context. And all of the code, all of the work that it does, and any API calls that it makes, like fetch calls or set timeout or anything like that, we're going to hook onto it and persist this context. So this code ran because of the interaction. The code it scheduled ran because of that interaction too. And the code that scheduled ran because of that interaction too. So it's just like turtles all the way down. Inside that code, if you update the page, if you call any DOM APIs, you add content to the page, or you toggle styles, or whatever it is that you do on the page, there's a long list of things that we observe. We're going to say, okay, the interaction that caused this code to run was the interaction that updated the page. Okay, we split it up into pieces. So at the end of the day, you get a whole page DOM, some of which was recently updated by one interaction and some of which was recently updated by a different interaction. And finally, as your page paints, as your page updates, as things load, we just map it back to the thing that caused it to happen. Okay, and there's a big project ongoing right now. There's some excitement in this area about container timing, and it's about being able to describe this. Large parts of the page collectively painted updates to the page, and we want to sort of nicely summarize it into a single bow. So this is kind of the demo I wanted to show today. So I showed you snapshots of the API as it exists in an origin trial that's still currently active in Chromium. Here, I'll prove it to you. This is, I was going to demo interaction to next paint, but y'all are experts. I think you understand. So I'm going to switch to, I don't know. I like using news.google.com because it sometimes depresses me. And I'll turn off mobile. So yeah, I'm sure you took my word for it originally, but if I refresh this, you see the green rectangles showing up. And if I was to use a normal off-the-shelf stable Chrome browser, as I interact to switch sort of the news sources, I would have no insights whatsoever in this loading. But now you get these yellow things, okay? So I will refresh, switch here, clear this out, and I will, so the original page, started, the first thing that appeared on the page was this, heading says Canada. The next thing that appeared was maybe this subtext, and then finally this image showed up. So over about 200 milliseconds, actually pretty quick on this network, there was this progression of paints. And I think if I refreshed it and we looked at a film strip, you'd see this like progression thing, pretty common. And yeah, I'm not going to show the LCP entry. Now, if I interact with this other one, it's very similar. This particular page, almost immediately within 53 milliseconds, presented something to the screen. And I guess it updated the styling on this heading over here. About 600 milliseconds later, it updated this, and then finally that image loaded. So it kind of has a very similar loading profile to when I hard navigated. It just was rendered completely differently under the hood. But again, as a developer, this feels entirely natural, very similar, right? It's like boring. All right. So here's something that we are basically convinced of changing before we prepare to ship this API to the public and give it available. So at the moment, the shape of this API, the actual entries here, literally borrowed the largest contentful paint performance entry. So you'll see directly in line, the element and the timing and stuff like that, because that's kind of what we want. We want updates every time the largest content changes. I'm going to switch to an experimental Chromium. And if I did it right, let me double check. I just want to show you one thing. I think I have to toggle this. Okay. We're almost there. We're almost at the punchline. So similar to before, you get a progression of updates. So the one difference that we're making is we're evolving the interaction contentful paint into a container timing. Okay. We're not going to ship the full container timing API, but we want to model it as container timing because the whole page is updating as a big container. And one of the values inside this interaction is the current largest contentful paint. Okay, so we just moved the stuff that was directly in there into a nested one. So if I open this up, you get the typical LCP stuff, but you get the total number of pixels that were updated in this whole quote unquote container. And then sometime later, there was a new paint and then another paint and then another paint. It might be that the largest content has not changed, but the page continues to render, the page continues to update. So we think that's useful to developers. We hear a lot of feedback about like, yes, it's very interesting that LCP is useful, but I want to know when it's fully done rendering. So now you have that choice. You have your cake, you can eat it too. Hopefully that's not too surprising. And this gives you the total number of pixels on the page that updated. And maybe that's it. Now you have a better intuition for what literally is shipping, how it actually works. Cool. Hopefully you enjoyed that. And hopefully the news I was casting, I wasn't reading it. Hopefully it wasn't too terrible. So we had a first version, but 2 years ago, it went through its origin trials. We decided at the end of that we had validated the concept, but not the implementation. We started over somewhat. That went through its origin trial, much better results. We wanted to change the API. We are currently in the last origin trial extension. So you have about 2 more months to use it in the field. And then we need to decide go or no go, can we ship it? And so we're quite confident. And so we're preparing to ship it in Chrome M150, which will be available to you in about 2 months. Yeah, lots of really good developer feedback. There's going to be a long list of improvements, but like the API is pretty solid. The use cases are mostly working out well. And it's time to go get that value.
The Core Web Vitals or the curating, so we want kind of so
the current expectation is there's no new Core Web Vitals, the same mental model. So what happens is if you interact and it soft navigates and you have this interaction contentful paint, we sort of elevate it up to the soft LCP. So it's just the same. Then we slice the performance timeline because you have a new URL. And so INP resets, CLS resets, all the old values go to the old URL, all the new events will start going to this new URL. So at the end of the day, it's the same Core Web Vitals program. You still have navigations. They still have 3 pillars. It's just expanding the data set. So there's like a bit of an interop issue because not all of these navigation types will be measured, but you could segment. And so we could say for hard navigation's traditional thing, here's the data, here's this augmented one. How we do the rollout is going to take more time. Right now, we want to give developers the ability to optimize.
Is this going to show up in DevTools?
Yeah, actually, I could have demoed that. Today already, it shows up in DevTools. So even if you don't enable features or whatever, like stable Chrome, if you do a performance recording, in small ways. So for example, there's like a line every time you navigate. So it's like there was a navigation here. If you click on it, you find out what URL navigated. So the long profile, it's like nav, nav, nav. So we started saying nav, nav, nav with like an asterisk. If anybody's done a recent trace, it's like nav star. It's kind of a nav, wink, wink. And then there's an LCP, but then you get an LCP star. And so if you notice, why is it a star? And you click on it, you get some metadata. It's quite useful. And we actually, tracing helped us realize that like we overcomplicated it, and then developers looked at it and it didn't quite align. And so we simplified it and actually made it better for tracing examples, and sort of helped us validate some of those changes. Like when do you start a navigation, and sort of we simplified it. So there's a little bit of integration. I think more is coming. The real-time panel, that is not done yet, but that's coming. And over time, more and more tools. But I think a lot of devs already noticed, like a lot, they were like, I saw tweets and. All right, thank you.